Hey, awesome people. Mr. C with another fractions video. Make sure if you learn anything new at all, click that like and subscribe button. Join us as we continue making math understandable and challenging. This video is going to be our practice problems video for subtracting fractions with unlike denominators using models. You will find the teaching video in the description below if you missed that. Also in the description is 2nd grade, 3rd grade, 4th grade, and 5th grade fractions. Check all of that out. Parents, teachers, you'll also find 2 IXL links. IXL is an incredible program I've used in my classroom. It is a great way for students to get independent practice and to track their learning. A great tool for 20-25 minutes at a time. All right, one link is for a 7-day free trial and another one is for a 20% off membership, whether that's annual or monthly. Check those out. Again, this is our practice problems video for subtracting fractions with unlike denominators using models. Let's challenge ourselves, awesome people. All right, people, here we go. As we always say here at Math and Mr. C, let's make sure we have the correct mindset. The correct mindset we're looking for is a growth mindset. A growth mindset means that we may not be able to do something yet. Yet is the key word. The more we practice, the better we're going to get. The more mistakes we make, the more our brain grows. Ask good questions, stick with it. Do not give up when it gets hard. Okay, so here we go. We've got 3/4 minus 2/3. Feel free to pause me anytime you need. First thing I'm noticing is the denominators are not the same. So because of that, eventually you probably could solve this without having to do these models and stuff. But right now, we're not there yet. Okay, we're not there yet. So let's draw some models. Let's do that by drawing 3/4 and let's draw 2/3. So I'm going to use rectangles like I always like to do to represent 3/4. And then I'm also going to represent 2/3. So here we go. So draw 3/4 on the left. Need 4 sections. 1, 2, 3, 4. Shading in 3 out of the 4. 2/4, 3/4. There we go. Now let's represent 2/3. And what I'm going to do is I'm actually going to represent it horizontally just because that's kind of what we've gotten in the habit of. So I'm going to draw it horizontally. So there's 1/3, 2/3, and 3/3. Shade in 2 out of the 3. There's 2 out of the 3. So there's 2/3. So we've got 3/4 on the left. We've got 2/3 on the right. The models are both the same size, but the pieces are different sizes. These are fourths, these are thirds. We need to find a common denominator for that. So what we need to do is we need to create equivalent fractions for 2/3. And we need to create equivalent fractions for 3/4. And that's what we're going to do next with our models. So going to copy these models, bring them straight down. I'm going to redraw what we already have because I want to keep the models above us still there. Okay, I want to make sure we keep that there so we know what's going on. So draw the same thing. That's the wrong color, Mr. C. There you go. Once we have redrawn these, what we are going to do is we are going to represent 3/4 on our model for 2/3, and we're going to represent 2/3 on our model for 3/4. Okay, notice my first model I drew vertically. My second model I am drawing horizontally. Students always ask me, Mr. C, why don't you do it the other way? And I always say, because I want to be consistent. Okay, I like to do my math the same way. That way I can find the mistake if I'm making it. If I'm always changing the way I'm solving a math problem, a lot of times I'm not going to be able to find my mistake. And also my chances of making a mistake get a lot higher. So if I do the same way over and over, One, I get better at that way, but two, I can kind of find my mistakes. And once I've mastered doing it one way, sure, switch over and do it the other way. All right, but I'm going to go vertical, then horizontal. So we need to represent thirds in this model here. So I need to draw thirds horizontally, 1/3, 2/3, 3/3. Now I need to represent fourths vertically. So there's a fourth, there's a fourth, and there's a fourth. 1/4, 2/4, 3/4, 4/4. Again, I'm trying to create equivalent fractions. I'm trying to find common denominators. So how many sections are there now in this model? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. How many are shaded in? 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12. Okay, so we've got 9/12. These fractions are equivalent. We created equivalent fractions. Now let's look at our purple model over here. How many sections are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 sections. How many are shaded in? 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12. Again, we created equivalent fractions. 2/3 is going to be equal to 8/12. Now, are our denominators the same? Yes, they are. They're both 12, so that makes it easy for us. Denominator stays the same. Subtract the numerators. 9 minus 8 is 1, and your answer is 1/12. How did we get to this spot? Mr. C, how did we get to 1/12? Great question. We had 3/4 and 2/3. Denominators weren't the same. So what did we have to do? We had to take 3/4 and 2/3 and create equivalent fractions for each of them. Once we created those equivalent fractions, notice this model and this model both have 12 pieces. They both have 12 sections. They both have common number, a number that's the same. Both of them have 12 sections inside of them. Now, the number of sections that are shaded in is different, obviously. We had 9 out of 12 shaded in. We had 8 out of 12 shaded in. But what we really care about is these denominators. They are the same. Once they're the same, it is so easy for us to solve. We just do 9 minus 8 is 1. Denominator stays the same. And we get an answer of 1/12. So, ask yourself, where did you get stuck? What didn't make sense? Where are you lost? Don't just say you don't get it, okay? Don't just tell your teacher, your parents, say, I don't get this. Show them where. Where are you getting confused at? Where are you getting lost? Because if you can figure out that, then we can show you what's next. It's just going to take some practice, okay? So stick with it. Do not give up. Rewatch this one if you need to. Walk yourself through it. Ask yourself, how did we get this model? How did we get 12ths? Where did 9/12 come from? How did we get our final answer? Ask yourself those questions. Walk yourself through it step by step. And once you've done that, I want you to try this next one with us. All right, let's do another one. Second problem here on the screen. We've got 5, 6 minus 1/2. Feel free to get started on this one. So first thing I'm noticing, denominators are not the same. So because of that, we are going to find common denominators. We're going to have to take 5, 6 and 1/2 and create equivalent fractions. And those equivalent fractions, we want their denominators to be the same. We want to find common denominators. So let's do that. Let's draw some models. First model I'm going to draw is my orange rectangle. You know what? Let's do it. Let's draw 5, 6. I'm going to move it over a little bit. And I'm going to copy it. And we're going to represent 1/2. Again, the way I'm going to set it up is I'm going to do vertical first and then horizontal. So I'm going to represent 5, 6 vertically. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Shading in 5 out of those 6. You can do vertical first and then horizontal. You can do horizontal and then vertical. It's really up to you. Just make sure you do the opposite. Okay, we can't have 2 verticals. We can't have 2 horizontals, because then we would just be drawing the fractions like right on top of each other if we did that. Okay, and we need to be able to see the 2 different fractions. So here you go. Here is 1/2, and there's 5, 6. Notice their models are the same size, but one of them is broken into 6. The other one is broken into halves. Okay, so I'll write that off to the side so we have it. And then let's do our next step, which is to redraw these models. Again, I just redraw them same exact way I have them. I like to do this. A lot of you are probably like, Mr. C, do I have to? No, you don't. Like, it's an extra step, and I'm all about not having to do extra work. I agree with you. I like to do it just so I can keep track of what's going on. It helps me kind of see my answer and make sure that everything looks good. Okay, 1, 2, 3, 4, 5, 6. So if you're doing it and you're like, Mr. C, I think I'm just going to draw it one time and then start working, cool, go for it. That's the cool thing about math, is once you get comfortable and once you kind of get used to solving it, you may not have to show every single step, and that's fine. But make sure that if you're not going to show every step, you're double checking your work, because it's so easy to make mistakes. I make mistakes all the time, and the reason I'm able to find those mistakes is because I'm double checking my work. Okay, so I'm going to double check it right now. I've got 5, 6, 1, 2, 3, 4, 5, 6, 5 of them shaded in, and I've got 1/2. All right, so I need to represent a halves on this model. To do that, I need to draw a horizontal line, just like I did in this model, because I need to represent halves over here. Notice if I would have had vertical lines over here, like if I'd had verticals, whoops, go back. Actually, let's go back. If I had had a vertical like this and shaded in, then I would just be drawing a vertical line right here, and that like doesn't do us any good. Like, how can you differentiate the 2 different fractions? You can't, because we just drew them on top of each other. It doesn't work that way. Okay, so let's redraw this real quick. Make sure, again, like I said, draw them in different directions, one vertically, one horizontally. So representing 1/2 over here, or excuse me, not representing 1/2, representing halves. Now let's represent 6th. So draw 6 sections vertically. 1, 2, 3, 4, 5, 6. There we go. Now let's figure out what our common denominator is that we have created. Let's look. Count all the sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 sections. How many are shaded in? 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12. So there we go. And what did we get in our blue model? Hopefully we have a denominator of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Good. Denominators are the same. That's good news. How many are shaded in? 1/12, 2/12, 3/12, 4/12, 5/12, 6/12. So we've got 10/12 minus 6/12. Denominators are the same, which is awesome. Our models both have the same number of sections. So denominator is 12, subtract 10 minus 6, and you get 4. Some of you may be thinking to yourself, Mr. C, can't you simplify that? And you are correct. You could simplify it to 1/3. Either answer is correct. How did we get this? Why did we get this? We got this because the denominators were different. They weren't the same. So we had to find common denominators. And that's how we got this model. And that's how we got this model. We found that the denominator 12 was a common denominator. How did we get that? Well, we drew 5, 6, and we drew 1/2, and then we broke those into the other fraction. Okay, we took 1/2 and halves, and we drew a horizontal line to represent halves, and then we represented 6 by drawing the vertical line, and that showed us our model created 2 models that have 12 sections. One model had 10 out of 12 shaded in, the other model has 6 out of 12 shaded in. Subtract them, and you get your final answer. So there's a lot of stuff going on there, and I know this can be a challenge, but it just takes time. It's very similar, like I said in our teaching video, to adding fractions with unlike denominators. It's very similar. The only difference is this symbol right here. Instead of a subtraction sign, it's an addition sign. Nothing really changes. Okay, stick with it, keep working hard, keep asking good questions. Feel free to reach out to me. My contact information is at the end of this video. Parents, teachers, I highly recommend you have students get onto iExcel for 20-25 minutes. Have them get some independent practice, have them work on it, master the skill. If they need more work, it is a perfect tool to use. Sit down next to them, throw problems up on the board, and work them out together. All right. If you learned anything new at all, make sure you click that like and subscribe button. Join us as we continue making math understandable and challenging. That's all I have for you. Mr. C, out.